Okay, so that heat exchange caused by different air temperatures, and those are caused by, well, the patterns of the sun, right? As well as currents in the water, which is also caused by the sun and some other rotational things, I suppose. Anyway, the fact that warmer air rises and cooler air falls causes wind shear and other instabilities like turbulence. Okay. Also, as water condenses into water vapor, right? So humid air has a certain visibility, but as the water starts condensing into clouds, well, the visibility decreases. Relative humidity is defined by the ratio of the amount of water that the air can contain, and that's dependent on its temperature and the pressure, as we saw in that PV is equal to nRT formula. And the relationship between the pressure, the volume, and the temperature also affects the water vapor ability to hold water vapor. So the dew point, right? Usually you find dew in the morning on the grass or on your cars and things like that. That's because the temperature is to the point where the air can't hold the water anymore and the water condenses and the air goes off, right? So on cold objects like a glass of water is a good example of that. Okay. I just threw in a map. I don't know if we showed that before, but generally, this was just a couple days ago, well, the 16th, and just the relative humidity you'll notice in the west and not around the coasts. You'll see the lowest humidities, whereas in other parts of the country, as far as this country is concerned, the higher humidities are in the east and on near the coastline and south, right? Okay, this was by the NOAA. I just got some of these screenshots from there. You can also get dew point information from the NOAA, and those temperatures are, it's based on temperature, dew point temperature, basically. So you'll notice, I guess the one thing to point out with this is the temperature at which it'll rain, basically, right? At which the air can't hold the water anymore is much higher in the higher humidity areas, right? In the south and east and coastal areas and things. Whereas the temperature has to be pretty cold to get the water out of the air in the drier areas, like the west. Does that make sense, sort of? Okay, good. I thought that was instructive. I think that's a good way to explain it anyway. Okay, got some pictures here, some what would be some indications, visible indications of stable air. Stable air is air that resists vertical motion, right? Convective kind of conditions. Okay, and well, here's two examples anyway. One is stratiform clouds in the upper right, where the clouds are basically all on a single elevation, basically. You can also see them as wispy clouds. These aren't as wispy, they're just kind of clumped, but the mountains in the background kind of indicate that those clouds are forming over the mountains because of the updraft. The wind blows in and gets higher and cools and condenses, and it produces clouds. So you may have more unstable air over those mountains in the background, but over dry land, that air stabilizes and those clouds just kind of hang there, right? So you have stable air. You wouldn't expect much turbulence flying in that kind of condition. Another indication of stable air is the smokestack, right? It's pumping out some steam, water vapor, and you'll notice that it's not going straight up into the air, right? You might have some wind blowing it, but even then, this looks like it's been, this picture is taken maybe several minutes to hours after the smokestack started pumping out its emissions. And a lot of the steam and emissions are just hanging around, right? So the air's not moving much, even with a little bit of wind. I mean, you can see the wind blowing the emissions out of the smokestack, but they're either falling a little bit or just hanging around that elevation. So very stable air is what you would see. So, and this is also an indication of stable air is not necessarily very clear, like your visibility may be pretty low. Okay. All right, so, and that leads us to the other part of the slide where stratiform clouds, low turbulence, it may be hazy or smoky, and it may even have rain, but it would be a steady rain, right? Just like an English rain, just kind of stays. As opposed to a thunderstorm where it blasts for a while in heavy rain and then goes away quickly. So, all right. We're good with that? Unstable air is more indicative or indicated by cumulonimbus types of clouds or cumulus clouds that are more puffy, and thunder clouds. Is that what they're called? Thunderheads, something like that. Anyhow, flat where the clouds have a flat bottom and tall, they have more vertical formation to them already. Unstable air is also found where the air is moist and warm. You'll find more turbulence, cumulus clouds, like we said. It's possible that there are tornadoes or severe thunderstorms already. And you can see those. In this case, you don't see rain happening, but maybe in the lower right, you're seeing some rain fall actually out of the cloud. Also, which may be counterintuitive, but good visibility is what you would see because the air is being drawn so fast, moving so fast, the humidity is being condensed quicker and not all of it, it's not spread throughout. All right, so good visibility is also a indication of unstable air with the clouds, typically. Okay, and so we talked about weather fronts a little bit. This is where different air temperature masses. So an air mass is just a group of particles of air that have similar temperature, right? And they move together typically. Okay, they usually come from two places. Polar air mass, so air from the poles will typically be cool and dry. That kind of makes sense. And tropical air mass would be moist and warm. So there are different kinds of fronts, and you don't have to know all these, but it's useful to know for flying purposes. I don't know. Yeah, I think you will see some of this on the exam. We'll talk about some fronts. Typically, warm front is where the front is named after the air that's moving, that moves into a place, right? So if you have a nice cool air mass over your town or whatever, and some warm air moves in, that would be a warm front. So the warm air moves into a colder region, and it would tend to rise because it's meeting a colder air, so it's gonna it's less dense, so it's gonna float basically on top of the colder air, thus creating cooler air and possibly condensation, most likely condensation or clouds and precipitation. Likewise, or conversely, a cold front is where cooler air moves into a warmer region, pushing that region air upward and condensing the water vapor out of the air and causing clouds and rain. An occluded front is where two air masses are moving in the same direction, and and similarly, a stationary front is where the two air masses aren't moving much. I think that's actually less than 20 meters per second or something. All right. The NOAA also has maps of fronts, and fronts are usually denoted by ISO lines of the leading edge of the air mass. And so let's see, pen. You can see a front. I mean, there's lots of lines here, but fronts are typically, here's the front measured in blue lines and red lines. Here's another cold and warm front. Here's another front line. Just here. Another front line. Another front line. Yeah, some. So typically we have low and high pressure front lines moving. Where they intersect is where those lines meet, or where those lines are drawn. All right. Wind shear. This is, where did I get this? I didn't have notes. This is a map of wind shear, and that is basically a, where the contours lines are in meters per second. So in the green, we're looking close to 60 to 70 meters per second, and down to 0 to 5 in the white, and so forth. So this is useful information for, well, if you're flying in that area. Okay. It's also an 84-hour forecast, so that's a 7-day, right? Or no, 3.5-day forecast. All right.
48 hours is 2 days.
48 is 2 days, yeah. So 84 is 3.5, right? Is that right? Well,
4 days.
4 days. Yeah, 3.5, I think. Okay, this I took out of the Airman Knowledge, one of those FAA knowledge study guides or something. We'll pull it up and show it to you. But basically, they go over the life cycle of a thunderstorm, and so I named it that. So first of all, you get some sort of condensation happening, where you have some convective currents happening. So the air then builds, so it has some sort of equilibrium level. So you have this dotted line at freezing, okay? And so the air, for one reason or another, convects upwards. So you have warm, moist air convecting upwards until it condenses near the freezing line, where it can produce hail and things. So as it condenses and drops, it causes more severe types of convection. So it pushes that plume of rain hitting the ground, cooling the air, forces the hot air upwards more, and creates, this is the mature stage, and can be up to 5 to 10 mile in height, and is the most violent and dangerous stage of a thunderstorm. This is where the most wind shear happens. This is the most unstable air. After the after the precipitation is nearly dissipated, this is the dissipating stage, and the air drops, and the convective currents nearly, well, dissipate and go away. So you have a few minutes usually of this mature stage, where really you want to stay away from these thunderclouds, and they can happen very locally or on a larger basis. And sometimes you can happen in where these thunderstorms can happen along a front and can be very violent and have many of them. So that's called a squall line. So you may have heard of that before. Okay, another thing to pay attention to is the kinds of clouds, and we kind of alluded to that as well. So stratified clouds are the stable air, indicate stable air, and that's the upper left or the top image where you just have wispy or just pretty much thin wispy clouds, right? Lenticular clouds are not as common, but maybe around mountains. So I found an image of a lenticular clouds around a mountaintop, and that's very unstable air. So you don't want to fly around that. And then you have your cumulonimbus clouds, which is basically rain clouds. And again, can cause very unstable air. Good. You also want to pay attention to wind speeds. And so a knot is roughly 1 mile an hour, a little bit more. So 25 knots at a mountain peak is where you would see this lenticular clouds. Well, anything 25 knots and more, you should expect to see turbulence and rising air and things. And 40 knots and above, you should take extreme caution. And as far as the drone pilot goes, that's sort of at the limit of most most drones to be able to stay there, right? To have stability. So yeah, you'd want to avoid those areas. Okay, other clouds. Basically, the only way to get water vapor into the air is from a solid, right? From ice or snow evaporating directly into gas, and that's called sublimation. Don't know if you've ever heard that in chemistry class, probably, or physics or something. So sublimation is basically, I thought I had a picture of it, but that's where the maybe sun is hitting the ice and evaporates the water right out of it. It basically goes from, if the pressure and the temperature have to lend itself to sublimation. It doesn't happen all the time. Liquid to gas, that's also very easy to see, and that's called evaporation, right? So you have sublimation from going solid to gas and evaporation, liquid to gas. All this has to have heat. Heat is required for these two things to happen. All right, the FAA also has what they call a ceiling, and you're not supposed to fly within 500 feet vertically of the ceiling and 2,000 feet horizontally of the clouds, right? And remember why? Do you remember why that rule is there? I think we talked about that, but that was a long time ago. So why don't you want to fly near clouds generally? I'm sorry, what? Yeah, you can't see, right? And so if an aircraft using instrument flight flies right through clouds, I don't know if you've taken many flights, but they go right through clouds as long as it's not dangerous. And all they know is what's out there by their instruments, right? Not by any visibility. So you're flying completely by visual flight rules, really. So yeah, stay away from the clouds. 500 feet below is the operative distance here, and of course 2,000 feet from the edge of clouds as well. Okay, so how do you know how high the clouds are? Well, there's a way to calculate it, but let's go over some terms here. Broken clouds are where you have, what is that, 5/8 to 7/8 cloud coverage of an area. So a little more than half, if you want to say it that way, 62.5% to 87.5. That's 5/8 to 7/8. Okay, and overcast is basically greater than that, just basically covered, right? Almost 100%. The term partly sunny, sure. I don't think they ever use that, but it's always going to be how much clouds instead of how much sun. Visibility is also determined or defined by the greatest horizontal distance that, well, significant objects can be seen, like mountains or your horizon, or, well, it's pretty much it, landforms, right? So the greatest distance that you can still see, like a mountain or horizon or something, is your visibility. Okay, in these METARs, the Meteorological Terminal Aviation Routine Weather Reports, I think they also call them terminal air reports or aeronautical reports. Yeah, there's another acronym that fits into, but anyway. You can calculate your cloud ceiling by taking your temperature spread and dividing it by 4.4 and multiplying it by 1,000. So what is the temperature spread? Is basically the difference between the temperature and the dew point temperature. That's your temperature spread. So delta T is the difference between the temperature, the current temperature, and the dew point, which out in the West is usually a pretty big number, right? Okay, so divided by 4.4 and multiplied by 1,000, and that's where you would expect clouds to form at that elevation. All right, so if we flip on over to perhaps the weather underground, maybe. See, and then we search for. Oh wow.
I don't see how they can bother the electric engines. It's not like they'd be sucking in though.
Well, in the bearings, yeah, very possible. All right, so today is 74 degrees, I guess, and right now, and let's see if we can find the dew point here. Dew point is 24 degrees, right? So that's the difference of, oh, that's nice of them, 50 degrees even. Nice. So back to, that's all we needed to know for this, right? So we have a 50-point temperature spread divided by 4.4. So let's pull up the old calculator, literally called the old calculator. So 50 divided by 4.4, and then that's equal to that times 1,000. So you would expect clouds at 11,000 feet, right? 11,363 feet, I suppose. Good. That's it. That was our example. We okay with that? Simple formula, figure out the cloud base. Now, those METAR reports will tell you your cloud level also, but just in case you didn't have that on you, you could fairly quickly get that. Okay, some other weather effects to consider as a pilot, right, is icing, right? You may experience icing on your drone if it's cold enough, right? Because even the metal parts and even plastic and the propellers, when propellers are moving, they cool, right? They don't get as hot. So that could, if you're really close to the dew point and the propellers are cooling the air, you could ice up on your propellers a little bit even, as well as on the drone itself. So what that does is it throws off your weight, and throws off your thrust ability, right? And so it can drastically and negatively affect the performance of the drone, and as well as any aircraft. And so icing is a big deal. And so it's usually they well, on airplanes, you have to de-ice before you even begin, right? Okay, hail. I don't think it pretty much goes out without saying. You don't want to fly in hail, so watch out for those thunderheads, right? Those, I don't know if that's the right term for it. Anyway, those thunder clouds, right? Those are the cumulonimbus clouds, and hail can easily exist in those. So the hailstones can form up in, at high altitudes. So even if it's somewhat warm in your area, you can experience hail, right? So there you go. Also lightning, that can happen as well. And not only can lightning just zap your drone, right? So what are the chances of it hitting you or the drone? Usually you want to fly in clear areas, right? So maybe your chances are elevated, but also lightning can affect your radio communication with your drone. So it can fly away on you potentially, given lightning. And I didn't put anything by tornadoes because I don't think I should have to say anything. You shouldn't even be outside, right? Unless you're, want to see a tornado up close with your drone, but don't expect to bring it back. Tornadoes typically, I guess I will say more about. They will have more wind speed than your drone can overcome, right? So your max speed on your drone is usually no match for the speeds of a tornado. So there you go. Okay, a couple words about fog. Fog can happen, right? It happens here as well as anywhere in the world. Not as often here because we have dry air usually. But fog is basically air within 50 feet of the ground, which is cooled to its dew point where the water vapor starts to condense. That's what causes, well, clouds, and it's basically ground clouds, right? That's what fog typically is. There are 5 types of fog. Advection is where warm air moves over a cold surface, and that requires about 15 knots. Any faster than that, it blows over it and it doesn't have time to form. Any slower than that, and it doesn't cover it. Radiative or radiation fog usually happens after sunsets in valleys where the cooling land or surface temperatures bring the air to dew point and causes fog to form in those areas. Typically, sunrise where the sun increases the temperatures and evaporates that water, or causes wind to blow the air out of there is how that kind of fog dissipates. Less common and less noticeable, and probably won't see too much. Steam fog is usually over water bodies like oceans, where the cold, dry air moves over the warm water. So the cold air condenses, evaporates the water and condenses in the cold air and causes sometimes that's called sea smoke. I thought I had a picture of that, but I guess not. Upslope fog is when fog is driven up a hill by wind, typically. Okay, fog can have ice in it. So flying through that may not be a good thing. And why would you anyway, right? I mean, flying in fog, you don't get very good visibility, so you wouldn't get very good imagery. So yeah, there you go. That can happen when the temperature is well below freezing. So the fog turns to ice very quickly. So that condensation can just ice up. All right, that is all we want to talk about. So I think we're ready to go over our quiz. You want to go over the quiz, or you want to try it on your own? All right. Sounds good. Sounds good. All right, it's a long, boring talk. Sorry about that, but it's all stuff that's all right. So what do we do? Preview it. Okay, what do we got? What is the characteristic of stable air? So there are several, but they're focusing on a couple things, right? So we have stratiform clouds, unlimited visibility, cumulus nimbus clouds, or cumulonimbus as a single term would be. A. Okay. And so, and that's true because unlimited visibility is more of an indication of unstable air, right? So, very good. All right, what are the characteristics of a moist, unstable air mass? Well, we have cumuliform clouds and showery precipitation, poor visibility and smooth air, stratiform clouds and showery precipitation. Well, I heard B. A. Should we vote? That's A, right? The cumulonimbus clouds are basically it. That's a vertical type of formulation of the cloud. Poor visibility and smooth air, that's the sign of stable air. Stratiform clouds is a sign of stable air, but you can still have showery precipitation with stratiform clouds. Okay, good. If an unstable air mass is forced upward, what type of clouds can be expected? Clouds with considerable vertical development and associated turbulence, cumulus clouds with little vertical development. Gee, that sounds kind of like an oxymoron, really. So that's one where you could probably throw that one out. Stratus clouds with considerable associated turbulence, which is also sort of. What do you think? A or C? What are stratus clouds? Aren't they the wispy ones? Right? And they don't have to be wispy, but they can have condensation in them, right? I mean, that's what clouds are, but clouds with considerable vertical development is unstable, right? So vertical movement is unstable air. Okay, so that's good. All right, question 4. A stable air mass is likely to have which characteristic? Poor surface visibility, showery precipitation, turbulent air. Yeah, didn't we already, we talked about 2 of these, right? So poor visibility is also a characteristic of a stable air. What about the showery precipitation? That can be it too, huh? So which one's a better answer? I don't know if this isn't a typo, because both of these are pretty good. Well, A and B are pretty good, right? Stable air mass it could be showery or poor surface. I kind of tend to do the poor surface visibility. But then again, I think surface, that's less concerning of flight. So unstable would be, so maybe showery is better, huh? What do you think? Should we take a vote?
Let's go with showery. More surface visibility.
All right. Okay. Well, I heard more B's, so we'll consider A and see if you're right. Because we'll remember your answer, so we'll see. All right, question 5. Moisture is added to air by evaporation and sublimation, evaporation and condensation, sublimation and sublimation. Well, we know it's not C, or maybe it's just C. Yeah, that's the only 2 ways we can get water vapor into the air, so, or water into the air. Yeah, I imagine that's the type of. Anyhow, question 6. Which combination of atmospheric conditions will reduce aircraft takeoff and climb performance? High temperature, high relative humidity, high density altitude. High temperature, high relative humidity, and low density altitude. Low temperature, high relative humidity, and high density altitude. Whew. How about that for a question? What do you think? Well, let's look at temperature. I mean, they're all about temperature, humidity, and altitude, right? So we can narrow this down. Let's start with altitude. Reduce aircraft takeoff performance, right? That means what in altitude? High or low? High. So it's either A or C already, right? Okay, good, good. So what about humidity? What does humidity have to do with decreased performance of the aircraft? Well, they're all high, right? So we'll skip it. Doesn't matter, right? But high humidity does decrease the performance of the aircraft. We okay with that? Okay. Okay, so temperature. What kind of temperature decreases your aircraft performance? High or low? The higher the temperature, the less dense the air, right? So I think high. So it's got to be A or B, but we also know it's A or C. So the only thing that makes sense is A. Okay, good. That's how you dissect that problem. We okay with that? It's a lot to think about, but that's how I would break that problem down and figure out what was the correct answer or the best answer would be. Is that okay? All right. What effect does high density altitude have on the efficiency of a propeller, of an unmanned aerial propeller aircraft? Propeller efficiency is decreased, propeller efficiency is increased, and it doesn't matter. It's decreased, right? The higher the altitude, the less dense the air. Forget about the word density, right? Just high altitude, lower propeller efficiency. All right. Question 8. Generally, for aircraft, the most hazardous kind of thunderstorm is? A warm, yeah, okay. A warm front thunderstorm, definitely. A stratoform thunderstorm, that doesn't really happen. I mean, it can, I suppose. Yeah, I guess. What about a squall line? That's a line of them, right? Along the front. So I would say that's a more dangerous, right? The most hazardous kind is a bunch of along the front or whatever, right? So very good. All right, what should you expect if you see lenticular clouds over a mountain? Strong turbulence, beginning of a thunderstorm, light to moderate precipitation. Yeah, I don't know about the thunderstorms. It could just be, right? But turbulence is the main deal. Right? You're seeing a lot of motion there. All right, which is formally defined as pressure altitude corrected for non-standard temperature variations. Density altitude, pressure altitude, true altitude. What? Yeah, we didn't define any of these other ones other than pressure altitude is based on pressure. True altitude is like your altitude. So yeah, none of it's other than that. So it makes sense. All right, what is the indicated altitude when an altimeter is set to 29.92 inches of mercury? Well, I think that's a little misleading, right? Well, it's a lot misleading, right? Indicated, what is the indicated altitude? Indicated altitude? Or when an altimeter, and that would think, okay, that's indicated also, right? And then they throw in when it's set to 29.92. So, oh, is it pressure? Is it indicated? So, yeah, I guess that's pressure, right? That's the pressure altitude. Yeah, it's definitely not density altitude. Yeah, I gotta think it's not as dumb as indicated altitude. What is the indicated altitude? So it can't be indicated altitude. I don't know. Well, like kind of, yeah. So All right, what is the standard air temperature and pressure at sea level? You would think, yeah. And do you remember the 15 degrees C, which is also what, 58 degrees, 59 Fahrenheit, yeah. And these other ones, what is this? Freezing, 32 degrees C is not even freezing, that's F, right? And then 30 degrees HG, you know, close. And then 98.6 degrees. Yeah. So you can kind of throw those away as you get it. All right, see if we missed any. I think there may be a couple there that we missed. Where is it? 11 out of 12. So we did miss the showery precipitation. We answered. So that was, you got it right? Poor surface visibility.
It's steady rain, not showery rain.
Yeah. So yeah, that's maybe where we got a little confused with showery and rainy, I guess. Nice. Okay, good. Right on. Let's pause that.